Controlled experiments are used in scientists to study the relationship between two variables. And so we're trying to establish cause and effect. The two variables are called the independent and the dependent variable. The independent variable, that is what I change. That's how I remember it. That I in independent reminds me that I can change that variable. So I can manipulate my experiment to discover something. I want to keep everything the same as much as possible and only change the one thing. During and after the experiment, I will gather data. So I will make measurements. The thing that I'm measuring, that is the dependent variable. It is the thing that gets changed based on the independent variable of the thing that I've manipulated. Control can mean two things. It can be a control variable, meaning that it's something that you're doing the same in your experiment. So for example, if I had plants, I would be watering them all the same amount. It also can be a group. So maybe I have a group of plants that I keep the same and I don't change anything about them. But then I'll have an independent group that I will look and change something in them. So then I'll be able to have two groups to compare. So for example, we could look at the relationship between mass and volume. So that would be my experiment, and this would be the experimental question or the title of my experiment. What is the relationship between mass and volume? So what I'm going to do is I am going to change the volume for different quantities of a substance. So we could use water. When I changed that volume, I could then measure what the mass would be. So I could add a little bit of water to my graduated cylinder, and then I could look and see what the mass is. And I could add a little bit of more water, record the volume, and then see what happens when I have more volume, what happens to the mass. So in this experiment, my independent variable is the different volumes. So I keep adding more water, I keep changing what the volume is in my graduated cylinder. My dependent variable, this would be the thing that I'm measuring. So I would be measuring the mass of each of those different volumes. The control would be, we would have the same person measuring what the volume is so that they're looking at the lines on the graduated cylinder the same way every time that they're reading it. Another thing that's a control is we would be using the same liquid. So we'd all be using water. When you are recording your data, the first column you will record that independent variable. So whatever it happens to be. So in our experiment that we just did with the volume and the water, I would put all my volume data in this first column. So again, the x-axis data, you need to make sure that you include a title with the unit. So if I'm measuring volume, I would put volume of water in milliliters, and then I would record each of those values down below. So for example, maybe I start off with 10 milliliters, and then I would record what the mass is. And then maybe I'd add 10 more milliliters, so I'd do 20, and then I record what the mass is. So a data table is important to organize your data so then it's nice and easy and accessible. So you can see exactly where all your data is. If you just write it in the margin, just chicken scratch, just a series of numbers, you might not know whether it would be the volume or the mass. So again, this one would be the volume in milliliters would be my title, and this one would be my mass in grams for this particular experiment. You should have a title on your table, and a good title would be Y versus X. So I would be mass of water with different volumes. And maybe you come up with a title that's a little bit different, but you should talk about the mass and how it changes with the volume changing. To help you remember what goes with what, you can look at this little acronym DRY mix. So the dependent variable goes with Y and the independent variable goes with X. So you know that if you have your x-axis here on the left-hand side, that is your independent variable. And if you have your y-axis here on the right-hand side, that would be your dependent variable. When you go to graph your data table, the title is going to be the same as your data table, but this is just a different way of presenting the information. So on your x-axis, that's going to be your independent variable. So it's just the same as that data table. And your y-axis will have your dependent variable. And then you'll be able to graph your data. Your graph should fill the space that you have available. So you should never have a really tiny graph off here in the corner, or maybe it only comes this high. You need to have a graph that fills the space. When you go and set up your graph, you want to be able to mark the x and y axes, and you want to always start at 0. So 0 is going to be here, and then you want to count consistently. So you don't have to mark and count by ones. You could mark and count by fives. So maybe I'm going to count by fives, 5, 10, 15, 20, etc. But you want to count consistently. So a piece of graph paper is very helpful just to help you mark the marks consistently. Obviously, I don't have graph paper here, so I did the best I could. I probably could have done a little bit better right here. But the point is I'm counting consistently, and it's by fives. Maybe my y-axis, though, to make the graph tall, I need to count by ones. And that's okay to be counting by fives on one area and ones by the other. The point is to make your graph look really big and fill the space. So if I didn't count by ones, my graph would only come like this high. And if I counted by fives on that other side. And so then that wouldn't be a very good graph because we really can't see the trend when it's so small. Sometimes we collect two data tables, and so we want to graph them on top of each other to show the relationship here. So in this sample graph, I have a hormone that's given to cows, and then we are looking at their milk production. So I would take data on the cows that didn't get the hormone, so that would be my control group. And then I would take data on the cows that did get the hormone and look and see what their milk production is. And so then it would be valuable to have both those data tables on top of each other so that you can see that relationship. So we can see here that adding growth hormone to the cow's feed results in more gallons of milk. And in this, notice that when I have two sets of data on top of each other, I need to have an answer key. And it is appropriate to write the word key there. And then to have different symbols. So here they used squares and diamonds. You could also use two different colors, but have some sort of key that describes what's going on in your graph. Otherwise, it might get too busy and you might not know what each line means. Again, I have my x-axis here. This is my independent variable. So I'm recording over time what this added hormone is doing, or looking at the control, see that things are just normal. And then here is my y-axis here. This is my dependent variable. So as time goes by, we see that the average milk production is increasing. Here's just another sample graph that has a key. This time we have 4 things that we're looking at, but the same thing applies. We have plant growth over time, and so we are looking at plants and adding juice and soda and vinegar and seeing what happens to their plant growth. So we'll also have a control where we don't add these different liquids, but you can see over time how the plant grows and see which of the liquids affects the growth the most. And so you can see that that vinegar, that the plant really didn't grow at all. But the other ones, the juice and the soda, they did a little bit better. So this graph has all the parts that we need. It has a descriptive title. That's the dependent versus the independent. We make the graph fill the space. We have a key because we have more than one thing that is on there. And we have counted with consistent intervals on both the x and the y axes. So some common mistakes are if you have your data points and they kind of look all over the place to connect the dots. So we're really looking for trends, especially in chemistry, we're looking for trends. And so when you connect the dots, sometimes it's hard to see the trend. It's best to do a best fit line. Most of the time in chemistry, we'll use a line graph. So here we have our independent variable of automobile speed and our dependent variable of the average cost of a speeding ticket. So you see that with increased speed, then the cost of the ticket goes up. Okay, so looking at a graph or a data table, you should be able to tell me the independent variable, the dependent variable. The independent variable, remember, is this x-axis, so this would be the auto speed. And the dependent variable would be the cost of the ticket. And we have a descriptive title, and we've counted at consistent intervals, and we've done a best fit line, and we've started at 0. Actually, I don't really like this graph. I just noticed that. The 0 really should be down here, so that's actually kind of bad. So we're going to see that the 0 is there and that we're counting by 40s. So 0 to 40 and then 80. That would be more appropriate to make sure that that 0 is right there where the x and y axis come together. In labs, I will have you write a claim. The claim will answer the title question. So you're basically answering the title question. For evidence, you need to provide evidence why your claim is valid with reasoning. And a lot of times the evidence is really just your graph or your data table. And the reasoning is connecting and putting it all together, taking that evidence and showing how it answers the title question and supports your claim.